So welcome to my class. My name is Gideon Kipkoech Kemboy and my registration number is 2023 EE154302 and my class is 2023 EEP April. The topic of today is the electrical power supply, that is the supply system. We are going to look at the power supply system and the typical AC power supply schemes. So let's start with the first one. That is the topic of today is the electrical power supply. That is it. Then we move to the second one. That is the electrical power supply. And first we are going to start with the definition. And the definition of what is the definition of electrical power supply? It is defined as the conveyance of electrical power from a power station to the consumer's premises. That is from the power station to the consumer's premises. It consists of three main components or three principal connections. That is the power station, the transmission line, and the distribution line. This power is normally generated or produced at power stations which are located at favorable places. Generally, they are quite away from the consumers. It is then transmitted over large distance or long distance to load centers with the help of conductors known as the transmission line. Finally, it is then distributed to a large number of small and big consumers through a distribution network. Now we move to the classification of electrical supply system. They are normally classified into two types. We have the AC and DC supply system. Then we have the overhead and underground system. The overhead system is normally preferred because it is more cheap, unlike the underground, where only underground can be used in places like the urban cities. These urban cities, an example of an urban cities maybe like New York or maybe London. So we move to the to the next part. That is the typical AC power supply system or scheme. In this part, the large network of conductors between the power station and the consumers can be broadly divided into two parts, i.e. the transmission system and the distribution system. These two parts, the transmission system and distribution system, has been divided further into two sections. There is the primary and secondary transmission. Then we have primary and secondary distribution. So we are going to look at the typical diagram, the layout diagram of the AC supply system. From our diagram, we have the generating station. The power is normally generated at the voltage of 11 kilovolts. It is later stepped up to 132 kilovolts by the help of step-up transformers. Then it is transmitted to the receiving station, that is the national grid station. At the receiving station, it will be stepped down to 33 kilovolts, then transmitted again to the substation at the voltage of 33 kilovolts. From the substation, it will be stepped down to 11 kilovolts, and from the substation we have those consumers that demand more power, so we can distribute them with the 11 kilovolts, and that part forms the primary distribution. Then we have the distributing substation. From the substation to distributing substation, in which we will step down the power from 11 kilovolts to maybe 415 volts or 240 volts. From the distributing substation, we now find the secondary distribution, where we will distribute this power to the consumers. We have consumers which will be consuming the power by it will be supplied with 240 volts, and others will be supplied with 415 volts. So let's start from the first part. We will take it from the generating station, primary transmission, secondary, primary distribution, and secondary distribution. So we start with the first one, the generating station, that is the GS. This is the generating station is where electrical power is produced by three-phase alternators operating in parallel. The usual generation voltage is 11 kilovolts, and for economy the transmission of electric power, the generating voltage is stepped up to 132 kilovolts or more at the generating station. The purpose of stepping up this power and transmitting them in high voltages, that is in 132 voltages, is we have several advantages. One can be saving of the conductor material. So the power has been stepped up to 132 kilovolts. So it will be transmitted to the receiving station. This part between the generating station and the receiving station, this part forms the primary transmission. The electrical power 132 kilovolt is transmitted by three-phase, three-wire overhead system to the outskirts of the city. This part will be forming now the primary transmission, that is from the generating station to the receiving station. At the receiving station, the voltage is stepped down from 132 kilovolts to 33 kilovolts. The secondary transmission. The primary transmission line terminates at the receiving station, which usually lies at the outskirts of the city. At the receiving station, the voltage is reduced to 33 kilovolts by three-phase step-down transformers. After the power has been transmitted from the generating station to the receiving station. At the receiving station, the power will be stepped down from the 132 kilovolts to 33 kilovolts by the help of three-phase step-down transformers. Then, from this station, electrical power is transmitted at 33 kilovolts by three-phase, three-wire overhead system to various substations or the grid substations located at the strategic points in the city. This section will now be forming the secondary transmission, that is from the receiving station to the grid substation. At the grid substation, we receive power at 11 kilovolts. In this part, we are going to step down this power from 33 kilovolts to 11 kilovolts. The 11 kilovolts we get from the three-phase step-down transformers. Now, the secondary transmission line terminates at the substation, where voltage is reduced from 33 kilovolts to 11 kilovolts. The 11 kilovolt lines run along the important roads of the city. This forms the primary distribution. It may be noted that big consumers having demand more than 50 kilowatts are generally supplied power at 11 kilovolts for further handling with their own substation. So when the power arrives at the substation, it is normally stepped down from 33 kilovolts to 11 kilovolts. Then we have the large consumers, that is the bigger consumers, which they are normally supplied with 11 kilovolts. So these consumers will be supplied with 11 kilovolts, and then they will step down on their own. Then we move to this part of from the substation to the distributing station, that is this normal transformers that will be forming our primary distribution. And in primary distribution, the voltage that is normally distributed is 11 kilovolts. And then we move to the last part, that is the secondary distribution. The electric power from primary distribution line That is, the 11 kilovolts is delivered to distribution substation. That is, I'll call it the transformers. The substations are located near the consumers' localities and step down the voltage to 400 to 415 volts, 3-phase 4-wire for secondary distribution. When the power has arrived at the substation, it will be distributed to the distributed substations. That is maybe the distribution. Then from the distribution substation, it will be taken out to the normal transformers. These transformers, we normally find them along the road. These transformers will step down 11 kilovolts to maybe 415 volts or 240 volts. This 415 volts and 240 volts are it is the power that is supplied to the consumers. We have different consumers who use different loads. We have those who use the single phase loads, and we have those who use the 3-phase loads. So if a consumer uses the 3-phase loads, he or she will be supplied with a 3-phase lines directly. Then we have the single phase, it will be the single phase. And what we mean by the single phase is that is a phase head and a neutral. Then for the 3-phase, it is normally 3 phases and a neutral. So I think this is the end of today's lesson. I will continue from the next part, that is the various types of supply system, in the next class. Thank you.